Okay, here we go. Last section on chapter 5, 5.7. Let me share my screen with you. And let's start by doing the graphing of a linear inequality. So go ahead and graph this is what we just did in 5.6. So just going to get you ready for that because we're going to do a lot of that here in 5.7. Okay, so one way would have been to put this into slope-intercept form, or could have used intercepts. Not the easiest numbers in the world, but that's okay. And then hopefully your graph looks something like this. It would be dashed, right? And notice that when we get to slope-intercept form, y is on the greater than side, so it generally means we're gonna, or it does mean we're gonna graph up, okay? Or use 0, 0 as a test point. And if you plug in 0 and 0, this is 0 less than 3. Yes, it is. So it would be in the shaded region. Okay. Your learning target. I will know how to graph and write a system of linear inequalities. You already know how to graph linear inequalities. Now we're just going to be doing systems, which means 2 of them. All right. So let's work together as partners. Match each linear inequality with its graph. Explain your reasoning. Okay. So here you have it. Which one do you think would be A? Which one do you think would be B? Well, we've seen that, well, there's a number of ways you could do this, but what we've seen is that when y ends up being on the less hand side, you're usually shading down from your line. So you're shading on the downward side, I guess you would say. And if y ends up on the greater than side, then it's the other way around. So one way might be to look at that. And you can see that if I isolated y here, it would be y is still less than or equal to negative 2x plus 4. So that would be a shading down. So I would think that that would be A. And then for this one, notice that after we subtract 2x, we'd have to divide both sides by negative 1. And when we do that with an inequality, we flip the switch, right? So this would end up being y is greater than or equal to, which means it would be this one. But there's actually another way. Did you think about the fact that what's the y-intercept for one of them? It's 0, isn't it? Yeah, this one's going to just end up being y is greater than or equal to positive 2x plus 0 if I want to. That means that that's going to be a solution, right? And that my line, my boundary would be right there. Obviously, this boundary is not there. So that's plenty enough to figure that one out. Okay. So now what we're going to do is we're going to take these same 2 inequalities, and we're going to graph both of them in one coordinate plane. And you can go ahead and use Desmos. So pull up Desmos, enter those in, and you'll see the results. And it looks something like this, right? You can see that I have my first inequality was this one, right, in red, and then it's less than, so it's shaded down this way, right? It's all shaded in here. And then for the other one, the inequality 2, that was the blue, right? And we would be, by the time we isolate y, it would be greater than or equal to, goes this way. Okay, so think about and describe what you think the 3 shaded regions and the unshaded region represent. Okay, well, hopefully you said that anything that is in this purple, darkish blue, I'm not sure what you get, is our numbers or ordered pairs or points that have ordered pairs that are solutions to both of the inequalities, in other words, solution to the system. What's in the lighter shade blue here is only what is a solution of one of the inequalities. The pink, only the numbers that are solutions to the other inequality. What does a white represent over here? Not a solution to either one. Okay, so that's what you can see there. Okay, all right. So what is a system of linear inequalities? Well, it's a set of two or more linear inequalities in the same variables. Just pretty much the same as when we did it with equations, other than we have inequalities now. Okay, a solution of a system of linear inequalities is what? An ordered pair that's a solution of each of the inequalities, right? In order to be a solution of the entire system of inequalities, it has to work for both or all of the inequalities if we happen to have more than two. Okay, so let's practice figuring out whether this particular ordered pair, 3, 5, is a solution to the system here. And you can see, so go ahead and do it. Plug them in, see what you got. Top one, 5 less than 6, true. Second one, 5 greater than or equal to 4, sure, it's greater than. So yeah, 3, 5 is a solution. Try B. Okay, so we ended up getting 0 is less than -4. Not true when I plugged it in just to the first one, which means, is that a solution to the system? No, I can stop right there because all they were asking me is tell me whether it was a solution to the system. And it's not if it's, unless it's for both. By not being for one, then the answer is no. Okay, go ahead and try a couple more of these. Okay, I'm back. And this answer would be no. And this one, hopefully you got yes. Okay. And again, remember, if I get no, if something doesn't work for the first one, don't bother doing the second one. Be efficient. Okay. So now we're going to actually get into graphing these. And this can be a little challenging at times. You have to really do a great job of being incredibly neat. And I would suggest using colored pencils to shade. Sometimes people like to use arrows and just do a bunch of arrows. But I think the shading works best, especially if you use 2 different colors. Some people have been able to kind of like shade with a pencil lightly, and then when they go back and shade again, it kind of makes it look thicker. Anyway, you just want to make sure that your system is really what's standing out, okay? So like in this particular case, that would have been this, right? This is where the pink coming off the red here and the blue are in, you know, that's their intersection is right there, kind of that little wedge there. Okay, so you graph them and then you see where the intersection is of the shaded areas, okay? All right, so go ahead and graph both of these. So you've got, the first one is a horizontal line, which is right here, and its y is less than or equal to 3, so I would shade down. And for y is greater than x plus 2, obviously up here at 2 is my y-intercept, slopes 1, up 1 to the right 1, dashed line rather than versus a solid line, right? And then we want numbers that are greater than, so we're going to shade up. So what's our solution? It would be right in here. Okay, try this one. Go ahead and pause it, give it a roll, and okay, here we go. So I put them into slope-intercept form, and then when you graphed them, hopefully you got that. So what do we have here? We had parallel lines, didn't we? Same slope, different intercepts, but we're shading away in each of them, right? The less than was the purple one here, right? The black was the greater than one, right? So shading up for the greater than, shading down for the less than, they don't intersect at all. So this would have been no solution. Now think about it, if the purple had gone that way and the black went that way, then we would have had this overlap right here. Okay. So you have to make sure you graph in the right direction. All right, so try this one. So again, if you love slope-intercept form, there you have it. And that's what the graph should look like. X plus y is less than or equal to 0, or y is less than negative x is right here in the blue. It's solid because it's greater than or equal, less than or equal to, excuse me. And we're shading down, right? Because it's a less than. The other, we're going to shade above because it's greater than. Okay. All right, so try this one. And if you happen to put them into slope-intercept form, there you have it. And then hopefully your graph got something like that. And where again is the solutions to this system of inequalities? In here, that double shade right there. Okay. Okay, so now I want you to write a system of linear inequalities represented by the graph. So we're going the other way. Over here in all the problems we just did, we took an inequality, a system of inequalities, and graphed them. Now you're given the graph, but you have to write the system of linear inequalities. But you can do this. It's easy, right? We just got to look at each of the lines separately and figure out what the slope is, what the y-intercept is, and then we can worry about if it's, you know, a less than or greater than, a less than or equal to, or greater than or equal to. So let's go with the dotted line. The y-intercept is right at the origin, so that's 0. And what's the slope? Did you get 1? Okay. Each box is worth 1. So yeah, it's 1. Up 1 to the right 1. Okay. So what? Let's see. It's dotted, so we know it's not an or equal to inequality. So it's got to be less than or greater than, and we are shading down, right? In order to get this overlap, I'd have to shade down from this one. So that's going to be less than. Okay. So y is less than x is the best way to write that. All right. With the other one, ooh, it's a horizontal line, right? So what's the y-intercept? Oh, -2. What's the slope? Horizontal lines have what kind of slope? 0, right? So we could plug in if we wanted to and have 0x, but you don't have to obviously leave that. So y is greater than or equal to -2. Okay. So again, we're trying to get this area in here shaded, and from this inequality, I'd have to shade up. So remember, they're only showing you the solutions. They're not showing all the shading, kind of like where we did here and, you know, in these problems. Okay, so they're only showing the overlap. Okay, so there's your system. Y is less than x, y is greater than or equal to -2. Okay, all right, let's try another one of these. Remember, they're only showing you the double shade, as I like to call it. Okay, all right, do the dotted line first. Okay, I'm back, and hopefully you had -1 and 2/3 for the slope. So you're shading, it's dashed, and you're shading up. So y is greater than 2/3 x minus 1. Okay, so now for the solid line, it's vertical. There is no y-intercept, right? Remember, because it's a vertical line, doesn't intersect the y-axis. So 3 is our intercept. So remember, slope, undefined or no slope, so you can't write it in that form. So how do we represent that? X not as equal to 3, but we're shading to the left towards smaller x values, aren't we? So it's going to be x is less than 3. So your system is right there. It's both of them together. Okay. So go ahead and try these and see how you do. Okay, so hopefully you got a y-intercept of 2, a slope of -1, vertical line, so it's going to be an x-intercept of 3, and a slope of, obviously undefined, it's vertical. So how would you write this one? Again, notice what we're doing. We're shading this area right here, right? So it's going to be, again, to the left of the vertical and down. So if that's the case, what is our inequality sign? Hopefully you said less than, and it's -2 plus 2. And then for the other one, obviously it's a vertical line, so we go and name it by, you know, all the points. So that's the 3 part, and we want smaller than 3, so x is less than 3. Okay. All right, try this one now. All righty, so hopefully you got those numbers for your y-intercept, your slope, and we want to shade up from this one. So it's gonna be a greater than or equal to because it's solid. And for this one, it's gonna be what? Less than or equal to. So hopefully you got that. All right. So again, be real careful in the way you think about these. And like I said, especially when you do your graphing, the neater you can be and the better you can be at your shading, it's going to go much better for you. Okay. All right. Let's try a word problem, and we'll solve this one by graphing. You have at most 8 hours to spend at the mall and at the beach. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. Good idea to spend more time at the beach than the mall, in my opinion, humble opinion. Write and graph a system that represents the situation. How much time can you spend at each location? Is there more than one right answer? Okay, so what should we assign and define our variables to be? Okay, X and Y, again, super creative. But X represents what? Maybe the number of hours at the mall for X and number of hours at the beach would be Y. Again, it doesn't matter which way you go with that. I could have put the beach with the X and the mall with the Y. You just would set up your equation, your inequalities a little bit different. Okay, so here we actually have 3 statements, right? At most 8 hours at the mall and the beach. So that means you would have X plus Y. Think about it, right? Hours at the mall, hours at the beach. At most 8 hours, so that means less than or equal to 8. At least 2 hours at the mall. Mall's what? It's X, right? So at least would be 2 or more. So X is greater than or equal to 2. And more than 4 hours at the beach. Beach was Y. More than, so it's just gonna be a greater than 4. Okay. So then if you went over here and you graphed them, so go do that. Remember, you're gonna have a vertical line, a horizontal line, and a diagonal line. And you're looking for where you got to shade really carefully when you're shading for 3. Hopefully you got that. Okay, so that would have been shading from in here for the diagonal. It would have been shading up here for the horizontal, right? And for the vertical, it would have been all of this. And if those overlap just there in that little triangle. Is there more than one right answer? Sure there is, yeah. You can see that anything on here, so like even up here at 2,6, that would be fine. 2 hours plus 6 hours is 8 hours, so we're still good. Don't have to do necessarily exact, integers for your hours. You could go, 2.5 and 7.5, although that would be too many hours. But you could do that. So yes, there are many possible answers, but one that works would be 3 hours and 5, or like I said, 2 and 6. Okay, awesome. And I think we got one more, don't we? Yes. Okay, name an ordered pair that is a solution of the system of linear inequalities. So basically you're just looking in here and saying, name any ordered pair that's in there. I don't know what, let's see what I did. 0, oh yeah, 0, 0, the origins, right? Okay, name an ordered pair that is not a solution of the system of inequalities. Could it be somewhere over here? Sure. Could it be somewhere over here? Sure. Could it be down here? Sure. Down here? Yeah. Anything that's not in the solid triangle. So like 0, 3. 0, 3 is right there. Not a solution. All right. Well, I hope you enjoyed chapter 5. Congratulations on getting through all the lessons on it. Now you just got to practice it and then go do really well in your assessments, which I know you can. All right. I'll see you.